first of all, I'll say thank you to all of you for joining us tonight. Our webinar tonight is on Pathways to Careers in NASA Science. We are so excited to have our three speakers with us, and I'll introduce them very briefly in a moment. But I do want to give a really big shout out and a thank you to the SEAS program and the Texas Space Grant for hosting this event, namely Selena Miller and Margaret Baggio. Some of you know them quite well, but without Selena and Margaret, we would not be able to host this presentation or webinar with you tonight. We're also thankful for their use of Slido, and Slido allows you to be able to sort of interact with us during the session with either surveys or word cloud generation about words that maybe you found impactful about our speakers, as well as to enable you to ask some questions for our speakers as well. So again, my name is Paige Graff, and I'll be sort of moderating tonight's session. Also on the line, Rosina Miller is with us, as well as Angela, Michael, and Kimberly Allums-Spencer. Now, all of us, Rosina, myself, and our three speakers, we are part of the Astromaterials Research and Exploration Science, or ARES division at the NASA Johnson Space Center in Houston, Texas. We do a lot of work, especially in the sciences, and you'll hear about some of our related work with perhaps Artemis or Mars or curation and more. And you'll hear the career pathways to our three speakers, Angela, Michael, and Kimberly Allums-Spencer. I want to welcome all of you, and our registrants today came from about 24 different states, Puerto Rico, and a number of different countries. So welcome to all of you that are joining us either live or on the archive if you're watching the archive recording. So we're going to start with Angela. So Angela, if you'd like to share your screen, we'll get started.
All right. So hi, everyone. And again, thanks you for being here today. I'm really excited to talk to you all about my journey to NASA. And so as Paige said, I'm Angela Garcia, and I work for a contracting company called Jacobs Technology at NASA Johnson Space Center in Houston, Texas. I am an exploration geologist that supports future human missions to the moon with the Artemis missions. There's a picture of me supporting an Artemis test event recently, but I'll get into a little bit more of those details later. And I'll just start by telling you a little bit more about myself. So I was born in Japan, actually the northernmost island called Hokkaido. That's where my mom and her family is from. But I grew up in Hawaii on the island of Oahu. So in that lower left-hand picture, it's that island in the center. So that's where I went to elementary, middle, and high school. And for those who might not know, Hawaii is in the middle of the Pacific Ocean. And so I grew up surrounded by these deep blue oceans and beautiful, lush green mountains and golden beaches and a star-filled sky. And I really was always curious about nature and inspired by nature, and always wanted to explore the world around me. And I knew I needed a career that would at least give me the chance of learning and being outdoors. And, you know, I heard we might have some high schoolers that joined from the islands. So shout out to you guys. I miss it so much. And so here are some of my favorite pictures from Oahu and the neighboring islands. That's my sister's dog, Aaliyah. She's a cutie. So after high school in Hawaii, I went straight to college at the University of Nevada, Las Vegas. UNLV is where I got my Bachelor's of Science in Geology. And, you know, while I was at UNLV, I started working when I was a sophomore in a lab on campus. And I started pretty much as a dishwasher, washing lab dishes like beakers and flasks in a geochemistry and microbiology lab that did planetary geology research. And that was actually where I first learned about planetary geology, which was kind of where I finally, that's something that really scratched the itch for me in terms of what I wanted to do, and taught me about exploration and was very satisfying on a much grander scale. So I feel really fortunate to have found that specialty so early in college in my sophomore year. But yeah, so I initially started working in that lab just because, realistically, I needed money. I didn't have a car, and it was on campus, but I also thought it'd be really interesting. And, working there exposed me to professional scientists and graduate students, and that really helped me be a lot more serious about my career and school. And when I was there, I asked a lot of questions and always offered my help to people who use the lab. And eventually that led me to apply to my own grants and scholarships to conduct undergraduate research under a mentorship. And that mentor was great and always forwarded me emails about different opportunities, one of which was a paid summer internship with Jacobs at Houston, Texas at Johnson Space Center. And, I applied, and that's where I went after I got my bachelor's of science in geology. And so also I'll add, in hindsight, like leaving Hawaii to go to college was one of the best things I think I could have done for myself. It forced me outside of my comfort zone to be independent. It also helped me with the freedom of a fresh start and gave me a lot of perspective that I don't think I would have had if I stayed. And so, everybody's journey is different, but for me, it was the right choice. And then here are some pictures of, supporting field work and doing lab experiments in Nevada. Even though I'm from a very humid climate, I also love the desert. Look at all these beautiful rocks. Okay, and I'll keep going. And so after my internship and my bachelor's of science in geology, I went to Idaho State University to get my master's of science in geology. And Idaho State paid for me to attend that school with a stipend, and they also covered tuition. And I'll say it's not uncommon for people in STEM to have their graduate school paid for and covered if you conduct research or if you teach at that university. And if graduate school is something that you want to do, that's definitely opportunities that you should seek out. My school was in a pretty small town in Idaho, but it was surrounded by a lot of beautiful mountains. And, that's where I got to explore when I was homesick. And, before I left Hawaii, I had, no idea how diverse and, gorgeous the mainland was, to be honest. I didn't think anything could beat Hawaii, but it's close. And living in, Hawaii, Nevada, and Idaho really made me fall in love with geology. So here's some pictures of hiking with friends and camping and being outdoors in some of these really pretty places. Okay, and so at Idaho State, I also got to do a lot of really cool research for the university, such as human and robotic exploration of different locations, some of which took me back to Hawaii, where we went to volcanoes on the Big Island to study conditions on early and present day Mars. And so that picture on the lower left, and learning about concepts of human operations on another planetary body. So that was an awesome project. And then also we used remotely operated submarines, that picture on the upper right, to study active underwater volcanoes off the coast of Big Island to Loihi, which is a submarine volcano, to study hydrothermal vents and study ocean worlds in our solar system. So there's some pictures of hydrothermal vents there, and also supporting some of that robotic exploration. And at those research projects, I got to work with not just professional scientists, but also professional engineers. And I really enjoyed, the applying my science to integrate with larger groups of people, and integrating with engineers and helping them prepare for, and test for missions. And I learned that there was a place for scientists outside of pure research, and I really enjoyed that. So actually, I did a year at Idaho State, and then I took a break and then did an internship back at Johnson Space Center with Jacobs. But I worked less in pure research and more on archiving, organizing Mars lander data. And the Phoenix lander, you can see that picture in that center. And while I was there, I reached out to scientists outside of the research division and expressed interest in maybe a change and trajectory of work. But I was still a student. So after I did an internship, I went back to school and finished my second year of graduate school. But while I was there, Jacobs did offer me part-time employment to work on projects that weren't just research, but more geared towards the moon. So that kind of led to that shift in work for me. And then, so after I graduated, I was then offered a full-time position at Jacobs to support future missions to the moon with Artemis. So Artemis is a series of missions to return humans to the moon, specifically the South Polar region by 2025. And these are, this is the first time humans have landed back on the moon since Apollo 17 in 1972. So it's been a long time. And so, like I said, Artemis is a series of missions. Artemis 1 and 2, which are starting this year, where we're going to send spacecraft back to the moon and then humans into orbit around the moon. But I primarily support Artemis 3+, which are the first human-landed missions on the moon. So that's when people are going to go walk on the surface of the moon again. Okay, next slide. So getting into some of the work that I do for Artemis, and one of those tasks is how I support Artemis as a scientist, more of an applied scientist, is that I evaluate hardware that's intended to be on the lunar surface with engineers who are designing that hardware. Here's me in a spacesuit mock-up in the rock field at Johnson Space Center. And a lot of these tests were at nighttime because we were testing spacesuit lights. So those helmet lights that you can see, and also supplemental lights. And I'm there to provide feedback to engineers on, how much details can I see in the rocks, as a geologist, and from how far away, and providing technical feedback to make sure that when we get to the moon, we have all the capabilities needed to make meaningful scientific observations with our lights. And lighting is really important because in the South Pole of the moon, the lighting is limited and complicated. And so we need to bring our own lights. And so, we have to figure out what kind of lighting is going to work best. So that's always really fun. And another way I support Artemis as a scientist is by helping to develop the structure of a future mission control. So these are events where I help to plan traverses for people who are going to go out into the field. If there's a picture on that lower right corner of people out in the field. So, we help plan those traverses, and then we sit at a simulated mission control console as a simulated flight controller at Johnson Space Center. So that's that big room on the left. And there we get to direct sampling and science targets and some of the traverses. And we're doing that by listening to and responding to the people who are out in the fields, their audio and their video feeds. So if you look kind of closely at some of the monitors on the left, you can see some of those video feeds and some of the maps that we're looking at. And really that's meant to help, learn how to structure a mission control for human exploration on a planetary surface, and really close the gap between how operations are currently done at the space station and how we'd want them to be done on the lunar surface. Because like I said, we haven't had somebody on walking and exploring on a planetary surface since 1970s with the Apollo missions. All right, next slide. And then another way I help Artemis as a scientist is by supporting, so not just hardware, but software development, testing, such as that in virtual reality. So there are virtual reality scenes like in a video game, but they're ones that are designed to mimic the real lighting on the surface of the moon, specifically the south polar regions of the moon. Like I said, the lighting is very complicated, and those long dark shadows can be very difficult to traverse. So they designed very realistic types of lighting. And in VR, you can walk around and take pictures and kind of put tags down and mark for samples. And I'm there to help provide science feedback on what details would be important for a geologist in an unfamiliar terrain to identify science targets and meet objectives. And VR is a solution and another way to train and learn about, unfamiliar environment than physically going out in the field and doing that work as well. So I think I might be tracking a little early, but I'll end on some final words, some advice that really helps, that, is kind of summary of my journey, where, seeking out, for me, seeking out mentorships and applying to opportunities in the field that you're interested in was really beneficial. Even if mentors, not all mentors are going to have time, or they're going to be really busy, but and if they can't talk to you, or if you don't get accepted into the scholarships or the grants or the internships you apply to, it's okay, because you benefit a lot from trying. If you're applying to things, you get, and the more you apply to, the better writer and proposer you are, and a better communicator you are, and so you just keep benefiting from putting in that effort, and you might strike gold. So I always say keep trying. Also, for me, working part-time and interning, like what you guys are doing, is really great. Interning in the field that you're interested in, and learning from the people around you, and asking a lot of questions and expressing your interest. And that really helps me bridge the gap between school and career. And then also, maybe a little cheesy, but, you can't underestimate the power of staying positive and working hard. That'll take you really, really far. So yeah, I guess I'll also end by saying, like, there's a lot of different flavors of scientists, and what I do is help to maximize science during missions and by integrating with engineers, and I really enjoy that work. And it took a couple of steps to find that niche that I really really enjoy, but it just takes some time. But always keep trying and stay positive. And I'm gonna stop sharing my screen now and turn it over to Mike.
Well, Angela, that was really fun seeing what you were doing. I've known Angela for a little bit now, and it was really interesting to see everything that you're up to. I think that speaks to how big and diverse the science here at NASA can be, is that there's so much that Angela's working on that I was excited to watch. So thanks for sharing that. And I think you tackled, I was looking at these questions, and there's a bunch of questions in Slido. So you hit a bunch right on the head, and hopefully my presentation can also help out with some of those questions. And if I don't get to them in this presentation, hopefully I can get to them afterwards as well. So yeah, my name is Mike Thorpe. I'm also at Jets and Jacobs down here at NASA Johnson Space Center. This is a picture of me in the field. This is one of the uniforms I wear. You'll get to see 3 of the uniforms that I kind of wear throughout this presentation. So I thought I would start off by giving you a little preview or a little timeline of where I started and where I ended up. So I would consider myself as a sedimentary geochemist. I was formerly trained as a geologist, got my PhD training in kind of sedimentary geochemistry. And I'm currently now the Mars Sample Return Scientist at JETS and in the NASA Johnson Space Center. But it all started with my roots in Cold Spring, New York. And I grew up just liking to be outdoors, hiking, really anything that got me outdoors was pure interest to me. And so I really didn't even know at this time that geology was even an option for me. I just knew that I wanted to do something that had me outdoors, getting my hands dirty and being outside. I then did my bachelor degree in geology at Towson University, and that's where I learned to just follow what I love to do. My parents always encouraged me to kind of just find something that I enjoyed doing. And so I had some great mentors at Towson University who were able to take my very broad interest of being outside and saying, hey, geology is perhaps a career path for you. And I had, at this point, no knowledge of planetary sciences at all. And so I went to Stony Brook University and started my master's there, did my master's and PhD at Stony Brook University. And that's where I was enlightened about how rich the Mars sedimentary rock record was. And I'll try to show you this a little bit further on with my research, but Mars has this ancient rock record, which shows that it was very Earth-like at one time. And there was lakes, there was rivers, there were streams, and it was all carving out these mountains on the surface of Mars. And if we could flash back in time, it probably looked very similar to places that we see on Earth today. And so this was really fun for me during my PhD. It was to be opened up to this kind of new environment and take my skill set that I was learning and apply it to a different planet. It was really exciting. And then I did a NASA postdoc, or I applied for the NASA postdoc fellowship. And it was kind of a joint fellowship where I had a mentor here at NASA Johnson Space Center. It was Liz Rampey, and then a mentor at Rice University, Kirsten Seebach. And we were working on a project to kind of use Earth as kind of an analog for what we were seeing on Mars. And so just taking my PhD research and kind of expanding that a little bit into different areas of expertise. From my postdoc, I started picking up this mission operations work. And there's some questions in Slido, and hopefully I can help answer some of those too. But I do a lot of work with the Curiosity rover, and I particularly work with one instrument on the Curiosity rover called ChemMin. And that's what I can consider kind of my fieldwork on Mars, is that the Curiosity rover is up there. It's our geologist on the ground. It's analyzing samples for us, and it's returning data to us, and we're interpreting that data. And then the last part of my kind of work here, or the last two pieces of my work here are my field work on Earth. And so this is where I do #MarsOnEarth. And so I try to go to these places on Earth and compare them to what we might have seen in the ancient rock record of Mars. And so what was happening on Mars very early in time. And I use all the knowledge from that timeline leading up to this to kind of operate as Mars sample return scientists here. And so we're preparing for samples to come back from the surface of Mars at one time. And that's with the Perseverance rover is currently on the surface of Mars sampling. And I'll show you a cool little video that shows you what the rover looks like when it's sampling. I think it's important to note, though, that as I depicted that previous timeline from where I started to where I ended up, that it doesn't have to be a perfect straight line. And in a lot of cases, it perhaps meanders. And that's what I have here is a picture that I took from a drone in Iceland showing a meandering or a braided river leading into a lake. And so if we reposition kind of my timeline in here, we can start in my roots in New York there. And I want to, for each kind of step of the way, I want to highlight here different hardships or different barriers that I had to overcome. And I don't want to do that to put pity on me and say, woe is me. I just want you to show that if you work harder, if you put your mind to it, and if you just follow what you love, sometimes you can get places that you couldn't even dream of. And that was just the case for me. And so when I was growing up, as I told you before, I had no clue that geology was even a possibility or a plausible career option. And now I'm a geologist for a living, and I couldn't love more what I do. Early in my life, I was purely focused on sports. And if you asked me when I was probably in high school, I probably wanted to be in the NFL. Obviously, that dream is not something that came to fruition. But nonetheless, I'm truly loving what I do now. And I just think that you don't necessarily need to know what you're doing from the jump. And so don't let that discourage you. Just let it use as motivation moving forward. And then at Towson University, I was actually told by a professor to consider changing my major and that I wouldn't graduate on time. I decided not to heed that advice from the professor and decided to push forward. And I couldn't be more grateful for just putting my head down and working hard, graduating on time, making it into graduate school, and where I'm currently at now. And then for my PhD and master's, I actually got rejected from almost every graduate school I applied to except for one. And so one university took a bet on me, and I'm thankful for that opportunity. And I took that opportunity and ran with it. And that's where I got introduced to planetary sciences. And so this was new for me at the time. And so all these previous parts of the meandering river, I couldn't even have pictured working at NASA until I was probably in the later part of my PhD. And so again, that's just to emphasize that you don't need to know from the start, and just kind of have fun along the way. And then the last two hardships that have been across the board here is there's one project I work on it's called the Dig Mars project. It was the first proposal that I ever wrote as a postdoc, and it got accepted. And even after it got accepted, and it's a pretty big deal that it was accepted, people told me it was kind of beginner's luck. And that's just something that, you tuck away in your back pocket, and you just keep working hard to continue to prove those people that have put you down in the past. And then just to emphasize, I'm currently the Mars sample return scientist here, but I probably had more than the amount of jobs turn me down than I would like to share. And so it just, again, if you look at this meandering path here, the kind of model that I always live by myself here is just work hard, continue to ask questions, step outside the norm, and just do what you love. And so here is kind of the next part of my research, the part that drives me as a scientist, and that's really because I'm a geologist stuck between worlds. And so on the left here is Earth, and this is a picture just kind of showing the geological record of carbon cycling. And this is just showing you that as we weather basalt, because basalt's the kind of rocks that I study for the reasons of looking at Mars too, it also sequesters carbon. And so there's purely an Earth interest for me because it's directly related to climate change, directly related to kind of climate change ancient in our history as well. And so there's a fundamental reason for looking at the stuff that I'm looking at Earth or on Earth for kind of informing where we're going on Earth. But then I'm also a geologist very interested in Mars, and basalt's particularly interesting because it's only made of basalt, whereas Earth is primarily composed of kind of granite, a fundamentally different kind of rock. And so that's where the two different fields overlap, is that we're studying basalts on both Mars and on Earth. And so the first part of my research will start with Mars, and this is a mosaic taken by the Curiosity rover. It's pretty surreal just to sit back and look at an image like this. And so in the foreground here, you see these dark dune fields. You would definitely see these in places in Hawaii where Angela was talking about. There's just these beautiful basaltic sands making these dune fields. And then in the background in this picture, you see these awesome layers of sedimentary rocks that stack up over time. And each of these layers are giving us a different piece of the history that happened at that point in time. And so here are the two rovers that I kind of work with now. The one on the right, I work with Curiosity, but we will be working with the Perseverance at some point in time with Mars sample return. And so this is just a quick video showing you the Perseverance rover as it's getting ready to sample. It's the first rover that has the ability to drill into the rocks, into the surface of Mars. And it's going to be drilling there. It's going to be storing these into sample tubes and eventually bringing them back at some point. And this rover is about the size of a minivan. Well, the Curiosity's one is running at the same time. So eventually we are going to take about, I think, around 30 to 40 samples, and they're going to come back within a couple missions to Earth. And we're in the midst of preparing for them now to analyze them. And so that's part of Mars sample return. And you'll see it's kind of going to drop it off in its body here. And then the other part of the rover work that I work on is with the Curiosity rover. And it's kind of the twin of Perseverance. It's the same body style. It's still about the size of a minivan. And I work with the Chemin instrument. So the Chemin instrument takes drill finds, which are kind of dropped off into the body of the rover, and then it peppers it with X-rays. And so those X-rays, just as if you were going to the dentist, are telling us something about kind of the material that it's X-raying. And so the X-rays are diffracted in a different manner. And then we analyze them on the back of this detector here. And as you'll see with the rings that start to show up here, each ring is kind of a fingerprint for the mineral that's in that rock sample. And so we can tell a lot by that rock sample just by looking at the X-rays here. So that's kind of the work that I'm doing on Mars currently. And if we flip to the Earth side of things, this is an image of us doing fieldwork in Iceland last year. We go to Iceland because it's made of basalt, and I already gave you my spiel on why basalt was important. But we also go to Iceland because the climate is cool, and it's a good paleoclimate analog for Mars, because we think that Mars was very Earth-like, but we think that it was probably very cold. And so it was probably Icelandic-like. So I do a lot of work in Iceland. And the work I do in Iceland is part of this Dig Mars project. And one of the things that we're doing is kind of drilling on the surface or on the edge of these lakes. And we're trying to get these drill cores so that we can extract them and look at what's going on with the sediments as they're interacting with groundwater, interacting with lake water. We bring those back into the lab and we analyze them back in the lab. And so it's really cool to be on this project because it's a part of a huge team. And that was one of the answers that I've already given in Slido, was that one of my favorite parts about working at NASA is the amazing teams that you get to work with. And so we have teams that span across the nation and across the globe in some cases. And so the individuals, the scientists, as well as engineers that come from these teams are amazing folks to work with. And it's thrilling to be working on science that you truly enjoy doing with individuals that care just as much about it with you. And so this was our study site in Southwest Iceland. If you were ever interested in hearing more about it, then by all means, follow up with me. And so I'll leave you with the three uniforms that I wear. So on the right was the kind of the fieldwork uniform that I have. And then on the left is the everyday casual wear that you can wear at NASA which is probably considered formal at times. But just to button up and working with the rovers on a daily basis and sending up commands to the rovers, telling them where to sample next, but also analyzing the data when it comes down. And then in the center is kind of how we have to suit up to go look at the samples that are related to Mars sample return in the Mars 2020 mission. And so I'll finish, and it's a bit cliche, but it's true to me, and I hope it's true to some of you out there. And that's just to love what you do and do what you love. And I'll finish there, and I'll pass it over to Kimberly, who is a great colleague of mine, and I've had a joy of working with over the years. So I'll stop presenting. I'll try to answer some questions in Slido, and I appreciate you listening.
As Mike said before, we do work together on some Mars 2020 work. So I've had the opportunity to work at NASA for the last 14 years. And so this is kind of my journey to NASA. It's a bit unique and a little bit interesting just because it's not a straight path. And so I was born and raised here in Houston, Texas. I attended high school locally and played varsity volleyball, basketball, and track. And I graduated number 9 in my class. And I've always wanted to work with computers and design and things like that. So the advice I got was, well, if you want to do that, you should go into electrical engineering. And so that's exactly what I did. I attended Prairie View A&M University, where electrical engineering was my major. And of course, I lived the college life and joined a sorority and another engineering organization. And in between having the fun, I interned with Lockheed Martin in Denver, Colorado as a sophomore. And one of the things that I remember the recruiter telling me was that, wow, you're an engineer major and you play volleyball for the university. They were like, how are you balancing that work and you still have above a 3.0 average? And so that was one of the things, like during my undergrad years, that really impressed the recruiters and basically got me the internship with Lockheed Martin in Denver, Colorado. During my tenure at Prairie View, I also worked for the Center for Radiation Engineering for Applied Radiation Research, which is now the Center for Radiation Engineering and Science for Space Exploration. And so that's kind of where I got my start that led me to the path to NASA in the first place. So again, I played volleyball for the university. We were actually conference champs my last year in school, graduated cum laude, and I applied for a fellowship to attend graduate school, and I did get that. So off the University of Florida I go. I decided to major in material science and electrical engineering with a specialty in electronic materials. And so electronic materials are pretty much semiconductors. They're in everything we have, like from your phone to your computer. They're everywhere. So these are the basis of all of our electronic devices. And so that was my concentration. During my tenure in grad school, I had 2 co-ops with Lockheed Martin as a part of my fellowship agreement. And then I also co-opted with Kodak company up in Rochester, New York. So I had the opportunity to move around quite a bit and see some, different places to live during co-ops. My 2 co-ops were actually here in Houston at NASA. So we'll keep that in the queue for how that helped get me to where I am today. So those were actually local co-ops here in Houston through Lockheed Martin at NASA. And so I graduated with my master's degree and PhD from University of Florida in material science and engineering. And some of my interests, of course, I love to read books, playing sports. I even play fantasy football. My husband loves that part. He's like, wow, you'll watch football with me every weekend. This is great. I love superheroes, cartoons, as you can see in my background here. Some of my favorites, of course, Wonder Woman and Storm, because they're really strong feminine characters, and I really think that's cool. And I like building things, and obviously I love riding my motorcycle. So one of the key things I wanted to kind of point out with this path and this journey to NASA was that there are points in my life I realized that what I call points of opportunities. So one of the points of opportunities that I really feel like made a big difference in where my life went was that I turned down a full-time job with Sprint in Overland Park, Kansas, coming out of school as a double E after I received the fellowship that I applied for on a whim. Like seriously, a friend of mine was like, hey, I got this scholarship application. It's for this gym fellowship. You want to apply? And I was like, sure, I'll apply. And so I did, not expecting to receive it. And so when I did receive the fellowship, I had a decision to make. And so one of the things I did was I weighed the value of getting my education right then, especially since it was paid for, versus going into the workforce, where I figured it would kind of be a little difficult to try to work and go to school. And so I just decided, I'm going to take this opportunity. I have this fellowship. It's just going to delay me a couple of years into the workforce. It should be fine. No problem. So that's what I did. And so again, I'm applying to all these different universities, and I was dead set. I'm going to Georgia Tech. You can't tell me anything. I am going to Georgia Tech. But then here comes University of Florida. They awarded me an additional $30,000 a year on a separate fellowship to combine with the one I already had. So at this point, I'm pursuing my master's degree. I've got one fellowship in hand. I've got another university offering more money on top of the fellowship. So you can kind of see where that choice went and how I decided to make that decision. As a point of opportunity, I took that. And I really believe from where I am now that that was one of the best decisions I could have made for myself at that time. Another point is I never planned to get my PhD. That was never in my mind. It was never something I strived to do. However, it happened. So 9/11 attacks happened in 2001. And at that point, I was about ready to graduate with my master's degree, and the job market tanked. People were not hiring. Things were, kind of all over the place. Folks were scared. People didn't know what was coming next. And so I had another decision to make. Do I leave school and try to join a job market that is pretty much frozen? We don't know where it's going. Things are all over the place. So at this point, I decided to stay in school. And so with deciding to stay in school, I said, well, I need more money to stay here. So I talked to my advisor, and I did what I now call the scholarship hustle. So I went over to the scholarship office, and I literally applied for every scholarship I could qualify for. I was online looking at scholarships, and I applied for anything that I thought I would qualify and could potentially get. And it actually worked out. I ended up receiving an extra $30K to go to school and continue my PhD. So all in all, I spent about 6 years at University of Florida pursuing my master's and PhD there in material science and engineering. And so the other thing is, during that time, because of those fellowships that had internships attached to them, those internships really opened the door for me to take on a permanent position with NASA, because I forged relationships with folks that remembered me once I got out of school. So persistence, regardless of what you're doing, one of the other key things I want to say is keep moving forward. So my path has not been the straight and narrow. It has not been an easy one, making my way from high school all the way to the permanent position that I have now with NASA. So my first year in grad school, it was my first time completely living alone, by myself, really far from home. And so depression starts to sit in. And I'm working, trying to go to class. I'm not motivated. I'm calling my mom on the daily, like, Mom, I want to come home. This isn't for me. I don't like being out here. I don't know anybody. And so my mom was like, you got to stay. They gave you money. You got to stay. You need to tough it out. You can make it work. And so instead of just kind of staying in that depression, what I decided to do was, I'm going to go be a student referee. It'll give me an opportunity to meet people in the intramural sports. I've already played sports. I love it. And so I started working as a referee. And to be honest, by the time I stopped working for University of Florida as an intramural referee, like, I knew so many people. It was funny. I was walking with one of my research colleagues while we were on campus, and we couldn't make it from our building to like the cafeteria without me speaking to about 15 people. And she turns and looks at me and she's like, do you know everyone on campus? Like, what is this? Oh my God. Like, how do you know so many people? And I told her, I said, I see hundreds of people every night in intramural sports, and we see each other so often. It's just kind of a natural occurrence to speak to each other and kind of be friendly. So that was one of the things that really helped me set aside the depression and get out there and get to know people and focus on my studies again. So some other setbacks with triumphs, like I said, were my research results were delayed during my master's degree. And so that's basically when the 9/11 attacks happened. Things kind of halted, folks were not traveling as much. The job market was in a hiring freeze. And so again, that's where I started doing the scholarship hustle to make sure I had enough funds to stay in school. And so my point to this is that no matter what you do, no matter how far down you think you are, find a way to keep going forward. So finally, we get to the career. So all through that, I have finally made my way back to NASA, and I am now a radiation test engineer for ISS and the Orion crew module hardware and electrical components. So I've had the opportunity to work, and this is when I was in the engineering department. So I've had the opportunity to work with many different projects across NASA, and very, some very good people, really smart engineers and everything else. And so my job was to test hardware that we want to put up on ISS. So one of the things you don't want to happen in a closed environment is to spark a fire, or you don't want to send up, something that's not going to work, because, weight is a precious commodity when you're putting things and people in space. And so some of the items we've tested were laptops, printers, iPad, because the astronaut said, I want an iPad. And so we were like, okay, we'll test you an iPad, make sure it works while it's up there and doesn't cause any safety issues. And so here I have a picture of some layouts that I did of the components that were in the laptop. I actually had the iPad X-rayed on site. And then we took it and I made the different positions to hit the components to see if they would survive the radiation environment of ISS. So the next 7 years. So at a certain point, after working in engineering for 7 years, kind of doing project testing, kind of ready to get back into the lab and do more hands-on work. As a test engineer, I was basically always taking other people's hardware and just testing it and kind of giving it back. But I really wanted to get back into that hands-on lab experience and lab work that I was used to doing being in grad school. And so this is where that career shift and that want led me to the science department at NASA, specifically working for Astromaterials research and exploration science. So I'm pretty sure you're wondering, how is it that this engineer is now working in the science department, no less, with geological samples such as lunar. We've got cosmic dust samples. We have Genesis samples, which are samples taken from the sun. And so it's just a weird transition when people find out. They're like, "You're not a geologist and you're working in Aries?" And I'm like, "Nope, I'm an engineer." And so it works. And I'll point out why that transition was such an interesting one. And so some of the areas I support now, when I started, I was a Genesis sample processor. I am currently an advanced curation project manager. I'm the OSIRIS-REx technical lead for that mission. We have return samples coming back September 24th of 2023. So we're in preparation for mission recovery ops for that now. I'm also the lab manager for Advanced Cleaning Lab, and I've supported other areas such as the Mars 2020 mission, Lunar ANCSA project, and also new lab design and construction. Oops. So here's the unique connection from engineering to science. So the Genesis mission collected samples using electronic materials, which is my specialty. And that electronic materials are semiconductors, materials such as silicon, sapphire, and germanium substrates. And so with Genesis, you basically put these samples out, these collectors, as we call them, out facing the sun. And as the solar wind and solar flares come off of the sun, those isotopes and those elemental isotopes and heavy elements get embedded into the material. So I also worked in clean rooms during my grad school years, which Genesis and pretty much all of our collections in Aries are housed in clean rooms. So this is another reason in the next photos, you will only see my eyes in the majority of the photos and probably have to guess that it's actually me. So the extraterrestrial samples, like I said, lunar rocks, they're all kept in clean rooms, keep them as clean and pristine as possible. And the other weird connection is that I studied radiation effects. And so essentially solar wind impinging on these samples are radiation effects at the end of the day. And so those are also an aspect of the samples that I study to be able to tell the PIs like where the actual solar wind is within the sample substrate. So here we are with a couple of pictures. It's me over here working with my colleague Carla. We actually had received a innovation award for our work in the Genesis lab. And just more recently working with some of my team on the OREX mission, we're over here trying to test a couple of in-house design sample containers. Just some other work I've done for OREX, cutting up wafers and making witness plates for mission activities to see what kind of contamination is falling out. And just other work with Perks working on site as we kind of get to go into mission control and some of the other historical areas. So that's always nice. And to just kind of finish it off, I want to say thank you guys for your time this evening. And if you have any questions, please feel free to ask away.
Great. Thank you so much, Kimberly, Michael, and Angela. You know, your career paths and hearing about them, it's just so very interesting to think about what sort of led you to where you are today. And so I very much appreciate you sharing with those that are on the line today. We do have quite a few high school students as well as community college and undergraduate students on the line. And so I think hearing your individual stories can hopefully help those individuals out there sort of find a connection perhaps with some of your experiences. So if Angela, Michael, and Kimberly want to share their cameras, I definitely want to take some time to go through the Q&A. Now, I know that a lot of questions have been answered in the Q&A from our speakers and myself and Rosina as other folks have been chatting. But there are a couple of questions that in our last 15 minutes or so that I want to make sure we can perhaps get some additional input on. And so one of the questions, and we're going to ask this starting with Angela and then Michael and then Kimberly. One of the questions that came in was, if you could give your past self a piece of advice or words of motivation, what would that be? So if you could give your past self a piece of advice or words of motivation, what would it or they be? So Angela, we're going to start with you. Not much time to think, but what do you got?
No, yeah, I think I answered that one in Slido 2, and I said to not be so hard, like to give yourself a break. Don't be too hard on yourself if you get rejected of something or you don't succeed when you first try. There's always going to be more opportunities, so don't feel discouraged. Also, if you get constructive criticism too, definitely don't take it personally. That person's trying to take time to help you improve. And so take all that with a grain of salt and just, try and improve from what they're saying. So that's what I would say.
Yeah, that's a great question. And I think I would kind of take it with another question that was in there. And that's just when you're in a career that you have such passion for too, you can kind of get lost in the work, but also make sure you enjoy every step of the way. I think when I was kind of progressing, I was always looking kind of what was my next career step and not enjoying each step of the way as much as I probably could. So, take time to pat yourself on the back to kind of, acknowledge where you made it and enjoy kind of the trip along the way, because it truly is, you get to meet remarkable people and it's just a fun time. So definitely sit back and enjoy when you make that progress too.
I would definitely say and agree with my co-speakers here is that do not be so hard on yourself when you hit those points where you're either rejected or maybe you didn't do so well, because those times are very brief. Those are only moments, and you get past those moments by keep moving forward and just saying, okay, this next go round, I'm gonna, do better at it and do my best. And so I think as long as you are always satisfied with the best that you have presented, that, you could have, there's nothing more you can do if you're always presenting your best, even if it's not someone else's best. You are confident in the fact that you provided everything you could, and you should keep moving forward because there's always another opportunity around the corner.
Awesome. And it seems like I heard a lot of, you do you, find your strengths and enhance those strengths as much as you can, knowing that you can really add value to everything you do. So great input from our three experts here. Related to this time I'm going to go backwards, starting with Kimberly and then Michael and then Angela. And someone has put in the question as follows. Passion careers are kind of notorious for resulting in sometimes difficult work-life balance. Do you find that true with your work at NASA, and how do you deal with that work-life balance? Kimberly, let's start with you.
Okay, so I think I began hitting that work-life balance right at the beginning of the pandemic, because right at that time, I literally applied for another position as like the advanced curation project lead. And I only had the position for a month, and the next thing you know, we're out on telework. And so I found my time at home being truly consumed by work, because there was such a steep learning curve to everything that was going on. And so I found myself working well into the night, whereas when we were on site, I was not doing that as much. It's like when I came home, work was done. And so I lost that work-life balance. And so one of the things I started to do is, while I love my job, I still had to set those boundaries. Like I could not continue to work through lunch or work well into the evening because I have a family. And so you have to set those boundaries, even in a career that you love, because you still need that self-care and you still need time, to do other things or attend to your family. Like you don't want to miss those moments with your friends as well. Having that passionate career, like that's great, but don't miss out on the rest of life by not setting those boundaries.
Great advice. How about you, Michael?
Yeah, I'm actually a huge culprit of this, and it's taking time for me to learn this, truth be told. And for me, my job takes me to Iceland for 2 weeks, and so like I lose that time with my family at home, and it's something that you just truly, like Kimberly said, with boundaries, you need to be kind of strict on yourself. And the things that I always remind myself are that, like, for me, family's number one, and then work, and then it goes from there. And so, whatever hierarchy you put things, you need to, put yourself and your family first, and then it goes from there. And so, slowly over time, I think I'm getting better at making sure that I stop at a reasonable hour. I get to play with my little daughter and take our dog for a walk and hang out with my wife. So just definitely knowing what comes first.
Yeah. So, I mean, I agree with what everyone said, and I struggle with work-life balance, but it's definitely possible to achieve that balance, and you have to want it. Things that have helped me, having a routine and a schedule and setting those boundaries, like Kimberly said. What's also helped is having hobbies, and making other plans and planning trips, like personal trips, because you buy that flight and you have to go, and you leave your computer and you make time for your friends and your family. And so it's being rigid with yourself. But if I don't do that, I will slip into an unbalanced type of situation. So I have to constantly be checking myself. So yeah, the career passion, it's easy to slip into, but it's definitely possible to have that balance.
You were going to add something, Mike?
Yeah, one more follow-up, and I think it's good to have Kimberly here too, is just to have mentors in front of you who also set that example. And so as you are increasing, as you're stepping up from kind of being the mentee to the mentors, like make sure you set that example for the people below you too. And so, I think that's important as well. And Kimberly sets a strong example of how to do such thing.
And burnout is a real thing, no matter what it is you do and what career path you have. So being able to keep that work-life balance is so important. But like Mike said in his presentation, do what you love and love what you do, and you'll never feel like you're working a day in your life. And so being able to do that and manage that, but not forget about the other things that are really important to you as an individual is so, so very important. So thank you for that question and for the great responses we got. Now, I think this question is perhaps geared towards Michael. And this individual says, I participate in high school robotics, and I'm hoping to pursue a career in robotic like Mars rovers. What would you recommend in terms of a major that I might think about?
Yeah, I think there's a couple routes you can go. I mean, there's a couple routes, and then from those, there's definitely different majors that you can go in each. And so the way that the rover, at least the Mars rovers that I work with, are that you have an engineering team and then you have a science team. And so within engineering, you can do a number, and I actually am not one to comment on what the engineering majors are, but I know there are a number of things to do. And in the science majors, you have everybody that's ranging from geochemists to astrobiologists to geophysicists. And it's just quite a slew of different majors that you can get. I will say that the communication that I have with engineers as a scientist is amazing, because as a geologist, I just want to go over and look at that cool rock over there. But the engineers are like, wait a second, we gotta pump the brakes. We can't just drive over there and cross over this, sandy patch. And they've been able to fix the rovers in times that, we can't get an oil change here on Earth. So we have to send up commands where we fix a broken drill on the surface of Mars. And so the engineering feats that they do are just remarkable. So if engineering is what you want to do, I would encourage you to contact somebody at JPL. Because you shouldn't be bashful about reaching out to people. People at NASA love what they do, and they should be able to recommend a path. If you want to know more about the science, then I can definitely steer you into different pathways that a major would be helpful for that.
And it's really so interesting to think about, there is no one size fits all. And being able to sort of show how you can apply yourself to any situation and be a problem solver, that's a really, really great skill. Here's another question that I want to throw out there for any one of you three who wants to sort of raise your hand to say, give your 2 cents. How competitive would you say the jobs are at NASA? Are there specific requirements coming out of school, or are there specific things you should put in an application to try to help yourself stand out? So anyone want to answer that?
I think for me, the connections that I made while interning proved to be the most important ones in transitioning myself from, college into a permanent job, because it was literally my manager that was my manager for while I was an intern. And once I got out of school with my PhD, like I hadn't seen him for or talked to him for at least 2 or 3 years at that point. And so he remembered me as being an intern, and he said, "Oh yeah, like, yes, bring her on. I know her. I remember her work ethic and everything else." Yeah.
I think we unfortunately might have lost her, but that work ethic, and actually one thing that Kimberly mentioned, perhaps not in this single word, but I'll mention it, relationships. As you build relationships with mentors or professors and things, those relationships and how you show yourself to those people, they remember a hard worker. And they remember someone who is engaged. So when you engage with people, they remember who you are and how you contributed to a given project. So that work ethic, I think, is a really important thing to be able to think about. So if Kimberly rejoins us or wants to add anything else to that, by all means, we'll want her to do so. Here's one question I just want to throw out there, because, this pandemic has really caused a different way in which people work these days. So perhaps we can start with Michael this time. How has the pandemic changed the way you work at NASA? And then we'll go to Angela, and if Kimberly's on the line, we'll see if she can give us input as well.
Yeah, so the pandemic changed us for a while there, that we were not allowed to be on site at all, and you had to be considered mission critical. And so there were things that we had to go on to do mission critical. And so it was interesting to be on site during the early stages to kind of be around people, but in a very, obviously messed up, and everybody was vaccinated and stuff like that. But since then, it's become a little bit more of, we're testing the waters with how much you need to be on site, with how much you need to be home. And so the way I think most of us are operating is that if you have lab work, you're going on site to do your lab work and what you need to do in person. And then if you have stuff that, you kind of leave after your lab work and work from home from those cases. And so finding the balance at home is kind of back to the passion thing. It is, when can we turn it off at home? And for me, it's 4:30 when Eliana comes home from daycare, and she comes in screaming, so the wheels fall off the house at that point for a few, and then maybe I'll respond to a couple emails in the evening or something like that. But again, making sure you maintain that balance.
Any thoughts from you, Angela?
Yeah. So I'll say I started full-time with Jacobs at JSC right at the beginning of the pandemic. So it's funny, but my first day at work with orientation, I was handed a laptop and said, "Welcome, go home. We're all going to work." You can't be on site right now. So I did my, a majority of the work that I've done here initially completely remote. So, I was trying to meet my coworkers and trying to, figure out some of the work that I need to do, and to work in these teams was really hard, but everybody was also struggling with it at the same time. So in that sense, it was pretty accessible. And I made sure to, get coffee outdoors and things with some coworkers to try and meet people in person. But a lot of the work I did initially was all remote. And then now, in the past 6 months or so, we're transitioning back on site. So it's great to, it's funny that you work with someone every day for 2 years, and then I just now get to shake their hand and say hello in person. So it's definitely shaken things up a lot. But it's nice to see people in person again.
Awesome. And Kimberly, if you want to give any input in just about a minute, because we're about time to close out on the working during the pandemic.
Oh, I think my colleagues pretty much covered it, but it is very much the work-life balance. It was a struggle to try to learn, a new position in this pandemic, and then still try to figure out how to get things done. So, we've been able to achieve quite a bit in that time frame, and so I think that's really important that when you hit an obstacle, you just need to find a way around it and work with your team to really figure it out, because work still has to get done, especially when you have a mission on the line and it's coming back. So, spacecraft's coming, we got to make it work.
Very, very true. And so, being able to navigate things is such an important part of any career, whether it's a STEM related career at NASA or anything else. And I wish we had more time, but in our last minute here, I just want to take a moment to, first of all, thank Kimberly, Michael, and Angela for sharing their career pathways. But I also want to be sure to thank Selena and Margaret from the Texas Space Grant and the SEAS program for their participation and hosting this event for us. We so very much appreciate you. And also to all of you students out there, we wish you all the best of luck in your career pathways and hope that these folks have given you some thoughts to think about as you pursue your future career in NASA science or something else.